I wanted to give you a scope shot of what the trigger pulse looks like on a bare coil using a regular magnet on one side of the coil and a superpole magnet pair on the opposite side of the coil as it goes by. This gives you an idea of what this new SG10 coiler looks like as I'm building it. I have two coils running the machine right now and two coils that are just sitting here idling. In other words, I could use them for generator coils, or I could just take a look at the pulse. So that's what we just did, was looked at the pulse on the scope. You can see it down the bottom right-hand corner. And I'm using the two of the leads are right there, and right here. I'm just looking at two. There's nothing cooked up here. This is where I have everything hooked up, and this is the setup. This is how I mechanically manufactured everything to hook up, just using a piece of angle iron. Thought I'd give you a quick look here at the partial completion of my 10 coiler. I want to show you the magnet arrangement. So far, I only have one trigger bus. I'll show you that here shortly, but I wanted to show you the magnet arrangement. Each coil here is a very, very close gap. I don't know if you can see it real well. We have a single magnet right here, but on the other side of the coil, we have a superpole north going on here. Now, if I look down inside the channel of these guys, you can see the superpole right in there. You can see the gap between those two. I haven't glued them in. They're just press fit in there for right now. But these little 30,000 sandwiches that I built allow me to glue the magnets on right here and just allow me to press them in right here. Now the whole objective here was to find out, I could either, notice that there's a U-shaped cutout in here. I could have laid the magnet down flat or stood them up and put a pair of them in here like this and just press them in. I could also do the same thing in this area right here. I could take this magnet off, put a pair of them in here, and sandwich them in between the slot in here. It'll allow for the magnet thickness in there. And these are just very, very light stainless. As you can see, I can flex these guys. The tape that I have holding on the outside is holding these guys from moving around from post, or I should say from station to station. There's a lot of flexing going on because they're so thin. The way I've mounted them up, you can see right in here, I have two bike wheels. I cut a notch out for this guy and a notch out for that guy. And if I show you up in here, you can see the little clamping arrangement that I've set up. I'll show you down in here. You can see the clamping arrangement a little bit better down in here. The support for this thing is just an outboard stainless steel support. We had laying around in the shop. I just made up out of a bunch of junk that we had laying there. I've got a couple of cross pieces up here that help support that thing. This whole thing is wanting to move laterally, so these diagonal supports just keep everything in check while this thing is running. This thing rotates extremely free. Looking at the bearing setup, I've got just a self-aligning needle bearing set up here. If I go to the other side, I can show you. There's a self-aligning needle bearing right here. I've got plenty of shafts sticking out here for some other ideas that I have going on. And I wanted to show you basically the kind of setup. I am not an electronic engineer. I'm a mechanical engineer. I've always wanted to take electronics, but I'm starting to learn that at age 60, okay? So bear with me. All I did was take a piece of angle iron and I mounted all of the transistors on the angle iron first. And here's another quick shot showing you the other transistors in here. Very simply, I just took and used a piece of the welding wire as my trigger bus, all right? Mounted my resistors onto the bus between the transistor and the trigger bus. And on the output side, here's my diodes. And this is my output bar, if you will, or output bus bar. And these are mechanically wired right up to each ring. The full ring, you can see all the way around this thing. It's a full ring, just like John was talking about. A full ring for the charge circuit, and this is for the ground. That's a full ring as well. And one for the top coil here. So far, I've had this thing running, and it charges just wonderfully. I'll back up here and give you a little bit longer shot here. I only have 7 coils on. 3 of them are on the bench waiting to be finished up. I ran out of components, so I'm waiting for that to go. Right now, I just had this thing fired up. As you can see, those 2 little batteries are hooked in series. Now, the reason I did this is just to put a load on the system. I know it's jury-rigged, but I just wanted to take these 2 batteries, this one, and use this for a temporary load. This is my primary battery. I know they're small, but and I know the wires are way undersized, but I just wanted to see if this thing was going to work. The thing I was interested in is I only have one trigger wire. It's right here, and that one trigger wire handles all of these transistors so far. I have not run out of power, and I'm impressed. Let me fire this thing up, get this thing going here, get everything hooked up the way it should be. Plug this guy in, and we're going to go to return here. Let me show you that real quick. All right, now we're not doing an extreme amount of RPM because there's a lot of wind resistance coming off this thing. There's those sandwich pieces that I put on those bike wheels, they create a lot of wind resistance. But take a look at the charging on this baby. Now there's only 7 coils on there so far, and you can see it's giving it hell. All right, so let's take a look at the transistor triggering. I'm going to put this on, shut this off for a second. All right, I just hooked up the scope, as you can see right on here. This is the last one. All of the triggering is coming this way. Yeah, I know we're going to run out of it. It's an impedance issue because it's in series here. It's not in parallel yet. It'll be a full ring eventually. But let's take a look at the triggering on here. I know we've got a double pulse here, and I don't have the right resistors on the firing circuit for these transistors for this particular setup, and I have those on order. Right now, these are 50 ohm resistors, and they're providing they're providing a double pulse here. I know I'm going to have to drop down and change that resistance a little bit, but so far I'm pretty happy with the way things are going on this thing. So I'll give you an update here later on when I get her finished up and see how this thing works. Okay, while I was showing you the scope shot here on the triggering portion of it, we got these batteries up. Now they were charged here about 10 minutes ago, so you know we're going up to 1578 on those 2 little batteries. But the amazing part is this battery right here is going down very, very slowly. I don't have a meter on it right now, but I checked it here just a little while ago, and I think it was down to 12.5, 12.5, somewhere in the neighborhood. But this thing runs extremely good. Everything is running ice cold. These transistors, when you put your hand on here, I mean, it's ice cold. And I'm going to guess the temperature's around 40, 45 degrees, somewhere in the neighborhood. It's cold. This is cold. You know, all of these tubes are cold. All of these lines are cold. So I must be on the right track because we have no heat in the system whatsoever. I'm pretty impressed with this thing.